Hey everyone, welcome back to my channel. Today we're going to talk about the humble cooling fan. We'll cover what they do, the different kinds there are, how to install them, set them up and optimize your fan curves to get the best out of them. Let's get started. First up, how do cooling fans actually work? Well, cooling fans use airflow to transfer heat away from various computer components such as the CPU, GPU, RAM, motherboard, and other electronics. They work alongside heat sinks, which are usually made out of metal fins that absorb heat from the components. The heat sink plus fan combo works by drawing cool air in and expelling hot air out. This prevents vital parts from getting too hot and potentially damaging themselves through a process known as thermal throttling, where the component reduces its own performance to stay within safe operating temperatures. By keeping our components running cool, we can squeeze every last drop of performance out of our hardware. As temperatures rise and fall, the fan will increase or decrease in speed to keep things steady. This is known as PWM control and is the preferred method for controlling fan speed, as it allows for much more precision compared to voltage control. Modern fans should have a 4-pin connector so you can take advantage of this. However, older fans may only have a 3-pin DC connector, and those will be controlled using voltage instead. The hot air exhausted from inside the case doesn't just disappear, it's pushed outside the computer by the fan. If you open up your case, you'll often find the rear panel or top of the case have a fan mounted on them. These are called exhaust fans. Make sure the exhaust fan has fresh cool air to pull through. Many cases also have fans mounted on the front or bottom of the case called intake fans. Many people worry about the intake fans sucking the crap out of their PC like some kind of cyber Hoover. While it is true that an excessive amount of negative pressure can cause some issues, these don't apply to modern computer cases. Just ensure you have an equal balance of intake and exhaust fans, and you'll be fine. More on this later when we discuss fan curves and balancing airflow. If you want to learn more about how computer cooling works, check out my video on heat pipes. And for info on liquid coolers, check out my All-in-One VS custom loop video. Next up, let's discuss the different types of cooling fans. There are quite a few different types of fans, each designed to serve a different purpose. In this video, we're mainly focusing on fans used for CPU and case cooling. But here's a brief overview of all the main ones. First is the case fan. These are the fans we just discussed that are used to keep the overall temperature of your system under control by bringing cool air into your case and exhausting hot air out of it. Some of these are mounted on the outside of the case, while others are mounted on the inside. CPU fans are attached to the CPU heatsink, either by screwing them directly onto the heatsink or by plugging them onto a 4-pin header on the heatsink itself. These are essential for anyone who isn't using a liquid cooler. And then we have GPU fans. These are built into the graphics card and come with the GPU. Their job is to cool the GPU itself and RAM by forcing air over the hot components. Moving on to radiator fans. These fans are used with liquid cooling and sit on the radiator, which is part of the liquid cooling unit. These can be set up in a push configuration where they draw air through the radiator, or a pull configuration where they suck air in towards them. Some people prefer push while others swear by pull. There's not really a definitive answer. And it may be worth trying both to see which works best for your specific setup. Finally, we have static pressure fans and high airflow fans. Static pressure fans produce higher force at the expense of lower volume of air pushed through. These are good for pushing air through tight spaces such as through heat sinks and radiators. Airflow fans move more air at the expense of less force. These are perfect for mounting inside a case for intake and exhaust. Now that we know the different types of fans, let's go over the sizes available. Here are the most common fan sizes you're likely to encounter. 40mm and 80mm fans are mostly found in smaller form factor PCs such as ITX builds. 120mm fans are the most common size and are compatible with most standard-sized cases. 140mm and 200mm fans are becoming increasingly popular and offer better airflow and less noise at the same given RPM compared to 120mm fans. Here are the main connector types you need to look out for. Most modern fans have a 4-pin PWM connector, which gives us precise control over the fan speed. Older fans may only have a 3-pin DC connector. These fans can still be controlled, but only via voltage, which isn't as accurate as PWM. You may also come across Molex connectors on very old fans. These plug directly into your PSU and run at full speed. Avoid these for modern builds. Let's now discuss how to install case and CPU fans. Please note that this guide does not include installation of GPU fans or radiator fans, as they're usually pre-installed or come with their own mounting hardware. For case fan installation, first power off your PC and unplug it at the wall. Next, identify whether the fan you're installing is an intake or exhaust fan. Intake fans bring cool air into the case and are normally mounted on the front or bottom of the case, while exhaust fans remove hot air from the case and are mounted on the rear or top. Some fans can be used for either intake or exhaust. Make sure you have an equal balance of intake and exhaust fans to create a neutral pressure inside your case. Too many exhaust fans can cause dust to be sucked in through any gaps, while too many intake fans can force dust out of your case. Mount the fan securely using the screws provided or anti-vibration mounts, if your case supports them. Okay? These are small rubber gaskets that help isolate the fan from the rest of the case. Many cases also have these pre-installed. Finally, plug the fan into either your motherboard or power supply unit. If you're plugging into your motherboard, make sure to plug it into a 3 or 4-pin fan header. Don't plug it into the CPU fan header, unless that's what it's labeled as. It's very important not to plug the CPU fan into anything other than the CPU fan header, as it won't work otherwise, and you'll get a warning in the BIOS. Also, try and route the cables neatly to ensure the best possible airflow. This also helps keep your PC looking tidy. Next, let's talk about CPU cooler installation. I'm not going to be able to explain every single CPU cooler in existence, because there are so many different ones. Instead, I'm going to demonstrate the installation of an under 15X compatible cooler, which is the socket used by Intel's 12th and 13th Gen CPUs, as well as AMD's AM4 CPUs. The process is similar for other sockets, so please refer to your cooler's documentation for details. The first step is to apply a precise amount of thermal paste to the center of your CPU. Then carefully line up the cooler with the mounting holes on your socket. Some coolers also have guides to help you with this. Once lined up, start lowering the cooler down onto the CPU, depending on your cooler. You may need to gently press down on the center of it to make sure it makes full contact with the CPU. Some coolers, such as the CryoFuel 3, have a separate heat pipe assembly that needs to be screwed down onto the fin stack. Follow the instructions for your particular cooler. Once everything is tightly secured, plug the fan into the CPU_fan header on your motherboard. It's absolutely critical that you plug the fan into the CPU_fan header. If you plug it into anything else, it won't work, and you'll get a warning in the BIOS. Double-check your motherboard's documentation to make sure you're plugging it into the correct header. Now that we know how to install our fans, let's go over how to check that they're working. First, enter the BIOS by pressing Del or F2 at the boot screen. Some coolers will automatically be detected in the BIOS even before you've installed Windows. Check your fan speeds here to make sure they're working and spinning in the correct direction. Alternatively, you can use one of the following pieces of software to monitor your fan speeds. On Windows, there's a program called Monitor, SpeedFan, and MSI Afterburner. For GPU fans, I recommend checking out GPU-Z as well. If you're running Linux, you can use the Sensors command along with the LM Sensors package. And finally, if you're using a Mac, there's a free piece of software called Max Fan Control. Finally, let's go over how to optimize your fan performance. There are several different ways to optimize your cooling fans. Let's talk about each of them. First up is adjusting your fan curves. This is by far the biggest factor in terms of optimizing fan performance. Your goal here is to keep your temperatures as low as possible without making your fans too loud. You can set your fan curve in either your BIOS or using software such as Argus Monitor or Fan Control on Windows. If you're running Linux, you'll need to run pwnconfig first to enable PWM control. Then you can use the Fan Control program to set your curve. As a general rule of thumb, you want to set your fans to around 50% when your CPU reaches around 60 degrees Celsius. This can vary depending on your hardware, so you may need to experiment to find the perfect setting for you. If you're setting up your fan curve in the BIOS, you'll first need to find the section called Hardware Monitor or something similar. Then navigate to the CPU or System Fan options and change the settings to your liking. Next is to make sure you have a good airflow setup. There are 3 main airflow setups you can have: positive, negative, or neutral pressure. Positive pressure means you have more intake fans than exhaust fans. This helps to push dust out of your case, but it can also put pressure against your graphics card and force air out of the vents on the back of it. This could reduce the cooling performance of your GPU. However, in most cases, this isn't a problem. Negative pressure means you have more exhaust fans than intake fans. This is good for cooling as it forces air through your radiator and heatsink, but it can suck dust in through any gaps or cracks. Neutral pressure means you have an equal number of intake and exhaust fans, which is usually the ideal setup for most people. You can also take steps to reduce fan noise. One of the best ways to reduce noise is to use PWM fans, as they're much quieter at low speeds compared to DC fans. As we mentioned earlier, you can also use anti-vibration mounts to help dampen the sound of your fans. And undervolting or underclocking your processor can also help, as it reduces the amount of heat your CPU puts out. Finally, make sure you clean your fans and heatsink regularly. Cleaning your fans will help to keep your airflow at maximum efficiency. Most cases have removable dust filters on the front, bottom, and top. Make sure these are cleaned regularly. You can blow out dust using compressed air every 3 to 6 months to help keep your fans running efficiently. That's it for this video. If you enjoyed it, please consider leaving a like. Now that you know how cooling fans work, why not check out my video on heat pipes to learn more about how heat is transferred away from your components. Thanks for watching, and see you next time.